All right, today we're going to be learning how to put positive and negative decimals on a number line and also how to compare and order them in a list as well. I think decimals are a little bit easier, maybe not on the number line, but when we compare and order them because we can think of money, which a lot of us have had experience with money and seeing like prices and stuff. So I think that it's going to be a little bit easier than the fractions. Just some background knowledge. We just need to remember that decimals are out of tenths, hundredths, and thousands. Okay, so here's our whole number or our integer. Okay, so right now we'll say we've got like 1.2175. Okay, that first decimal place is tenths. The second one is hundredths. And then thousands. Okay, so when we are counting on a number line, we either need to be counting by tenths, hundredths, or thousands. Okay, and we'll come back to that later. Just like integers, these decimals can be positive and negative. Which makes them rational numbers, which we talked about the other day. All right. Now, graphing these on a number line is going to be tough, okay? Just like how graphing fractions on a number line is tough. So take this video at your own pace. If you need to pause it, slow down, ask a question, do that because I need you to understand how to do this. So really work at your own pace here. So we want to graph 3.2 on a number line. Well, we need to know what two integers is 3.2 in between on a number line. Well, 3.2, think about like $3.20 is in between the whole $3 and having a whole $4. $3.20 is in between having $3 and $4. Okay. So what we could do is we could make a number line. Don't write this down. Where we put 0, 1, 2, 3, and 4. -1, -2, -3, -4. Okay, but that's going to be really crammed. So instead what we're going to do is we are just going to put a 3 and a 4 on our number line. Okay. And I need to get to 3.2. So I'm going to look at my decimal. I'm going to look at 0.2. And I'm going to think to myself, 0.2 is in the tenths place. Okay, 0.2 is in the tenths place. So I'm going to think about myself, can I count by 2s and get to 10? Yes. So can I count by 0.2 and get to tenths? Yes, you can. Okay, so that first tick mark after 3 is, and we're counting by 0.2, is going to be 3.2. The next tick mark after that is going to be 3.4 because we're just counting by 0.2. Next one will be 3.6, then 3.8, and then 3.8 plus 0.2 will be 4. We're going to put a nice big dot on where 3.2 is, and we have that graphed. Okay. 5.4. 5.4, $5.40 comes in between having $5 and $6 because you've got a little bit more than $5, so it comes in between 5 and 6. So I'm going to put my 5 over here. Since they're big numbers, I don't want to squish them all on this number line, so I'm only going to use the part that I need. Okay, because what this is this is a zoomed in number line. To this little section right here that's just in between 5 and 6. It's just zoomed in. Okay, we have 5.4. So we think, can we count by 0.4s and get to 10? No, we can't. But what could we count by that would get to 0.4 along the way, but would also get us to 10? A couple answers could be 0.1. You could count by 0.1 and get to 10. You could also count by 0.2 and get to 10. I'm going to choose to do 0.1 since we did 0.2 for the last one. If you chose to do 0.2 and you're just using the video to check, that's totally fine. Okay, just make sure it's in about the same spot. So we're going to count by 0.1. So this is going to be 5.1, 5.2, 5.3, which you could have counted by 0.1s up here too. 5.4, 5.5, 5.6, 5.7, 5.8, 5.9. And then the next number would be 6. Okay, I wanted 5.4, so I'm going to put a nice big dot on where 5.4 is. Again, I could have counted by 0.2s. It would have looked similar to what that last one looked, where this would be a 5 and this 4 would be a 6, and it would be 5.2, 5.4, and then we just have the dot on there, 5.6, 5.8. Okay, but you can always count by 0.1s or 0.2s, whatever's easiest for you, whatever comes to mind first. Okay, 0.2 and negative 0.2. We start our number line with 0. The closest integer that's larger than 0.2, remember integer, we're talking whole numbers, would be 1. That's bigger than 0.2. Closest integer is 1. Closest smaller integer is negative 1. So I need to make sure my number line goes from 1 to negative 1. Then I ask myself, can I count by 0.2s and get to 10? Yes, I can. So I can go ahead and do that. Always do your positive side first, because we've been doing that in elementary school. Okay, hopefully at least. So our first one's going to be 0.2. 0.4, 0.6, and 0.8. I'll put a nice big dot on 0.2 because that is a number that I'm graphing. Now remember, our number line is mirrored towards the negative side. So if 0.2 is my first positive value, negative 0.2 is my first negative value. It should be the same, just negative. Negative 0.4 would be my next one. Negative 0.6. Negative 0.8. I'm going to put a nice big dot on negative 0.2 because that's the one we were supposed to graph. All right, if you're feeling confident, go ahead and try the next one on your own. You can pause the video and resume it to check. If you're not feeling confident, follow along. Just at any time that you are feeling confident, like if I start setting it up and then you're like, oh, now I know what to do, just pause the video and then start to do it on your own at that point. That's okay too. Okay, so we're going to graph negative 1.5 and 1.5 on a number line. We want to know what number is larger than 1.5, but is a whole number. That's going to be 2. Okay, because 1 is going to be less than it. 3 is larger, but 2 is closer. We want the closest one. Closest smaller integer to negative 1.5 would then be a negative 2. It's going to be the same number, just negative. So on my number line, I've got my 0. Sorry, I just wanted to close out my email. I've got my 0, my 1, and my 2, my negative 1, and my negative 2. Now I need to think, can I count by 5s and get to 10? Yes. So I can start with my positives. 0, first would be 0.5, then plus 0.5 more would be 1, plus 0.5 more would be 1.5, plus 0.5 more would be 2. So a positive 1.5 would get graphed right here. Going negative, it's going to mirror the same thing. I've got 0, and I've got negative 0.5, negative 1, negative 1.5, negative 2. Put a nice big dot on my negative 1.5, and we are good. All right. Last thing we're going to do in today's video is we are going to compare positive and negative decimals with less than, greater than, or equal to. Remember, it opens up to the greater one, and the more negative a number is, the smaller the value. The less negative a number is, the larger the value. So I want you to pause the video and I want you to try to fill these out. Okay, do the best you can. If you have to make a guess, make a guess. I'd rather you guess and get it wrong because we learn from mistakes. Instead of just copying down what I'm doing, you're going to learn better if you guess and get it wrong than if you were to just copy what I do without even thinking. Okay. I also like to do a little trick of whatever one's larger when it's positive is smaller when it's negative. So if this was a 6.3 and a 4.9 positive, it would open up towards the 6.3. So since they are both negative, it opens up towards the 4.9. Negative 4.9 is less negative than negative 6.3, so it is larger. Same thing here. 0.44 is larger when it's positive than 0.11. So it would open up towards the 0.44, but that's if it was positive. Since it's negative, it's going to be the opposite. Negative 0.11 is less negative than negative 0.44. Same thing here. If I am doing money here, I've got $2.50. If this is positive, $2.05. So which one will be larger? Will be $2.50. But since they're negative, it's going to open up to the less negative one, which is $2.05. Okay. Same thing here. I'm always going to think about a positive first. Which one is larger when it's positive? We've got a 0.82 and a 0.89. 0.89 would be larger if it was positive, but it's not. It's negative. So it's going to open up to the negative 4.82 since that is less negative than negative 4.89. Last thing we need to know is how to order them least to greatest. Least to greatest, we are looking for the most negative one first into the greatest value, which is the least negative or the most positive. So if I'm looking at my negatives, I've got two numbers with a negative here. What's nice about decimals is we don't have to make common denominators because they're all decimals. So I'm trying to think which one is more negative, 0.3 or 0.37. Well, if I make 0.3 and I had another place value after that, remember we fill empty spaces with a 0. So that would be like a 0.30, negative 0.30, and negative 0.37. Which one is more negative would be the negative 0.37. So if you ever have a decimal that just has one number like 0.7, 0.3, you can always add a 0 to the end of it to compare it to that next place value. Next would be negative 0.3. Now we're done with our negatives, so we're just talking positives. I've got 0.7, 0, 0.25. Which one is the smallest amount of money? Well, $0 is the smallest amount of money. Then would it be 70 cents or 25 cents? It'd be 25 cents. And then 70 cents or 0.7. All right. And that is how we compare and graph rational decimals.